Alright, so 5.6 is graphing the other trig functions. So we'll be graphing secant, cosecant, tangent, and cotangent in this section. So this video or lesson is only going to be on cosecant and secant. And then we'll do another one with tangent and cotangent. So graphing cosecant. So specifically this problem, y equals 2 cosecant 1/2 x plus 2 pi minus 1. If you can change the reciprocal of cosecant is just sine, we know that. If you can graph the same equation with sine right there, you're about, I'd say, 80% done with the problem. Okay, so the first thing you want to do is literally just change that to sine and graph that equation. Okay, so we just had a quiz on it. You could find the amplitude, period, locator point, and up by. We just spent a few days doing that. Then we graph that equation, y equals sine. So I'm not going to explain how to do that. We should know how to do that. I do it in dashed curves just because this is not the cosecant curve. This is just the sine curve. We're going to use this sine curve to graph the cosecant. So your up bys are the same. You can see all the dots on the curve. All of that is the same. Okay, so once you get that finished, every time you have a sine locator, or every time this curve goes through this midline, these are all sine locators, draw a vertical asymptote. Okay, through all of those points right there. So the asymptotes also should be dashed because they are not a part of the graph. They're just used in order to find the graph of cosecant. Okay, so far we've just graphed it as sine, and I drew vertical asymptotes through all of the midline points, the sine locators. All right, and then the last thing is you have it, and now every time you have a peak like this, you just draw a curve that goes down, hits it, and then goes back up. Notice it goes closer and closer to that asymptote and closer to that asymptote. Every time there's a valley, it comes up, hits it, and goes back down. Comes down, hits it, and goes on forever. Okay, this darkened curve is the y equals cosecant of all that stuff. So the heavy lifting was done by the sine curve. Then we just draw our asymptotes and make the connections. Okay, questions on that? Yeah.
Okay, I'm just still kind of confused. So that's all we do is just put those on those
Yep.
highest and lowest points.
Right. Yep. And I'm not going to explain why right now and why there's asymptotes. I'd be happy to some other time, but we're just going to kind of take it for what it is for right now. All right, so now if the other thing that you'll be asked to do in these problems is find the domain and range of it. If you just look at the sine equation or the sine function, what's the domain of y equals sine x? Or anything with sine in it like that. What's the domain? All real numbers. Very good. It goes forever to the left and forever to the right. Okay, there's no holes in the graph. There's no points of discontinuity. There's no asymptotes in the sine one. Okay, what about the range of this sine one? Can you tell by the drawing up here? Is there a minimum and a maximum?
Yes.
Looks like it goes from what?
2 to like, I think positive 2 to negative 2. Or no, wait, sorry, that's top bottom. So like 2 to negative 4, 6.
Looks like it's -3 to +1. But it's hard to tell with the graph because you can kind of see there's -1, -2, -3.
Oh, great. So that's
Okay,
the one.
so the range for y equals sine, like the range of this right here, would be from -3 to 1. And we include -3 and we include 1 because it does go through it. Okay, so now, what about the cosecant curve? The domain, is it all real numbers? Continuity. Every time there's an asymptote. Very good. So if you're going to find the domain of this, it would be all real numbers except for when there's an asymptote. Okay, so you would start by saying all real numbers, but when x is not equal to the asymptote. So now we just have to figure out, how do I write the asymptotes, like using symbols, using numbers or variables. All right, so here's how to do it. First thing you want to do is find an asymptote. Now, which one? It really doesn't matter, but to be consistent and probably to align what's in the back, and what most people would do is, you have our y-axis right here. You want to grab the first asymptote that occurs at or beyond the y-axis. Well, there is one on the y-axis. That is at x equals 0. This vertical line is x equals 0. So we'd say all real numbers, x not equal to 0 plus, this is the first asymptote. And now we have to figure out, how often do these asymptotes occur? Is that true? Is it every 2 pi? Everybody agree with that? Yeah, so those are the two things to do. Find your first asymptote and figure out how often they occur. This happens every 2 pi. So plus 2 pi n. And n is an integer. This would be our answer, by the way. And you don't have to put 0. It's not wrong to put 0. 2 pi n. So let's say n, we know n equals an integer. That's what n does in math. N is an integer. So if n is 1, I have an asymptote at, plug 1 in for n, I get 2 pi. Yeah, there's an asymptote at 2 pi. If n is 2, well then we're at 4 pi. Yeah, there's an asymptote at 4 pi. What if n is negative 1? 2 pi times negative 1 is negative 2 pi. Yeah, there's an asymptote at negative 2 pi. It covers all of the asymptotes. As long as n is all real numbers, x not equal to 0 plus 2 pi n. Hagen.
Okay, so if there's no vertical asymptote on x equals 0,
Yep.
then, and let's say the next closest vertical asymptote is on just pi.
Yep.
Would it be pi plus?
Pi would go right there. Yep. And then whatever it's going up by.
Okay.
Yep. So this is right here. Good question. I don't know. What is that? How often asymptotes occur, or whatever they're going up by. I'm not going to write that out. Just made a little bracket. All right. What about the range? Possible y values. Is there a minimum? Is there a maximum? Anybody have an idea what the range could be? Oh, it's actually there. And that was probably a different problem. Do you see that it's everything until it gets to here, and then there's nothing, and then it starts again? So it goes from negative infinity all the way up to negative 3. And then it starts again at 1, and it goes to infinity. So that would be the range of it. All the way up to negative 3, and then from 1 to infinity. Using interval notation. All right, my video I will pause to answer the phone. All right, so trying another problem. The next page that I just explained everything we just did on the next page. So you didn't have to take notes about what we just did. I just have it all written out for you. Okay, so we'll try another one. This is a secant. So if we're going to graph this right here, you literally just change it to a cosine. So it's negative cosine and all that stuff. And you just had a quiz on graphing cosine also. So we graph it. First thing you have to do is take out the 2, and then find the locate or amplitude up by all that stuff, period. And you draw your dashed cosine curve. Well, then secant would be, and every time you have a midline point on the curve, we draw asymptotes, and then it goes down, hits it, goes up, and this darkened in curve is the equation, y equals negative secant, and that stuff. Okay, so really if you can graph cosine, you can graph the secant. So, domain, back to Keegan's question. Where is our first asymptote here after the y-axis? Where does my first asymptote occur? Pi over 4, very good. So when we do the domain, it's going to be all real numbers, x not equal to pi over 4. And then how often do they occur? We have to figure out how far that is. We could just take the top one minus the bigger one minus the small one. So 3 pi over 4 minus pi over 4 is 2 pi over 4, which is pi over 2. So the domain would be all real numbers, x not equal to, there's my first asymptote, and that's what it's going up by every time. Okay, the range, it goes all the way up to 0, and then it starts again at 2 and beyond. So it goes all the way up to 0, and then it starts again 2 and beyond. Alright, that's enough for today. We'll try a problem together here.